very nice function. That's hot. For example, f is a polynomial in variable x plus iy. Then this holds. Or also power series, it's hold. And actually, Cauchy, I think, never gave the reason of this, but this fact comes from the following fact. So this is an afterthought, and later, for example, Riemann clarified that is if g0 and choose a point z, and you say that point z goes to g0. There are many ways. So it's really two-dimensional things. So this condition is really strong. Therefore, this implies this. Why? Because there are very special case to approach to z0. The one possibility is just z goes to z0 parallel to the x real axis. In this case, this can be, so in the very special cases, I write now x plus I y 0, I y and x. Oh, sorry, I use the same. No, not good. What shall we write? Okay, I write x0 prime plus I y prime. This is our z0. Okay. And x plus I y minus x0 prime I y 0. This is a general case. But if you use a point, a z, which is and tend to this 0 along the parallel to the x-axis, means just you fix this part and take a look. And if this exists, it should be the same value. But this you know very well. This is given by df of dx x0 prime y0 prime. But also there is another way to come. Use now choose the z which is parallel to the imaginary axis. That's also possible. And this should be also the, if this exists, this should be also the same number. Then now, in this case, you fix x0 and there is 1.
Why you walk to the y prime? I think y.
Oh, because I use here x0, y0, sorry. Point.
I think y0 is okay. And no need necessary to y
Yeah?
prime.
Okay? Yeah, don't confuse this
Ah.
x0. I use it this way.
So this also needs y prime. Yes.
Yeah? Z is x0 prime plus I, y, y0. Yeah? And here, now x 0 prime, I fix this part and just. And now this case, I cost. And please be careful, in down denominator, now I. So this cancels out, what is I times y minus y 0 prime. So what you get is I over y and df of dy of x0 prime, y0 prime. That's okay? If this hypothesis holds by any z0, that implies that df of dx should be equal to 1 over I df dy. And this is the same thing to say y df dy. Okay? And then this can be, you can write down ds dx plus I times ds, no, dv. And here you can write down minus I ds dy plus I dv dy. Therefore, this is equal to dv dy minus I ds dy. Okay, so this part is real functions. So real part is equal to ds dx equal to dv dy, and dv dx is minus dv dy. So this one, you get it. And today we call this formula as a Cauchy-Riemann equation. And Cauchy used this part actually. And Riemann really proved that. Well, he defined that today we call the harmonic function is a function such that this always exists. And then you have this equal. So it's a very special function because, for example, if you consider f is x minus iy, this is also a function of x plus iy. But in this case, it doesn't. Yeah? This does not. Or better say that any power does not satisfy the Cauchy-Riemann equation. Equations. It's clear?
Yes.
Okay, you're clear. For other people, that's okay?
Then what's the relation between the interchangeability of the multiple
Pardon me?
integral and the Cauchy-Riemann equation?
No, wait, but still I'm not finished. Just I'm saying that this, not all functions satisfy this Cauchy-Riemann equations. So actually, it's a very special function which satisfies this Cauchy-Riemann equations. Okay? So, for example, this one doesn't hold. Please check by yourself. Especially n equal 1 case is very simple. Yeah, so ds dx is 1, and dv dy is now becomes minus 1, so this doesn't hold. But for any positive power, it's the same thing. Okay. So sometimes this is very confusing, but please be careful. So now Cauchy used this Cauchy-Riemann equation. And what he did is following. So now choose your fxy as this function, ds dx and dv dy. And use this expression to calculate this. For example, left-hand first example. So this gives you df this way. So you can write, that's okay, y0, y, dv, dy, and then dx. Okay. Then of course this can be easily integrated so that you get v x y minus v x y0 and dx. This is the left hand side. And on the other hand, the right hand side is use this part. The same way, y0, y, and x0, x, f, xy, dy, dx is equal to now y0, y, and now s x0, 0, no, x, y, minus s, x, x0, y, dy. Okay, so this is one formula. We get it. So x0 to x of v x y dx minus x0 x v x y0 dx equal y0 y to s x y dy minus y0 y s x0 y dy. So this is one equation. Sorry, I erased. But next is just apply fxy again. ds dy equal to minus ds dv dx now. Now apply the same things, but only be careful. This is now sign is opposite, minus. Okay. So now apply this, and then you get similarly x0 x of s x y dx minus x0 x s x y0 dx equal y0 of y now minus of v of x y dy plus y0 y v x0 y dy. Okay. So in this way you get two formula, and we want to derive this relation just using this f. So simple way is just multiply this this part I and take sign. That's okay?
This is the same small f x y. This f x y is the same with the other.
Which alpha?
No. If you make this support,
Yes?
if you make this support,
Yes?
and this one, this
No, it's different.
It's not
Now
possible.
I'll choose a different one. So this is a different function.
maybe f1, f2.
No, maybe I'm sorry. Maybe I like this is g.
G. Okay.
Now apply this formula.